In this presentation, I want to introduce you to a project that I developed for my college algebra students towards the beginning of the semester. With a little modification, this can also be used in finite math, pre-calculus, and calculus. In this project, students compare the total cost of two different insurance plans as the amount of medical charges increases. This project arose from an analysis I made of the two family plans offered by my own college. These two plans have very different premiums as well as different levels of coinsurance, copays, and deductibles. The Premier plan offers better coverage, but at a cost of $514 per month. The Basic Plus plan offers slightly less coverage, but at a monthly premium of $46. The out-of-pocket maximum for the Basic Plus plan is double that of the Premier plan. However, you pay 10 times more per month for that difference. My goal was to decide which of these plans I should choose. I wanted to pick the plan with the lowest total annual cost, assuming several visits to my doctor and a specialist. The visits to my primary care physician incur a charge of $100, and the visit to a specialist incurs a charge of $150. I will also assume a single generic prescription that is charged at a rate of $30 per month. To model the charges and costs in each plan, I'll make a table of values with the column headings shown here. The first column will be my independent variable that I will increase in a systematic way. The total medical charges are what the medical provider charges if you are not covered by insurance. The total medical cost is the corresponding amount that the insured party actually pays for those services. The prescription cost is what the insured party pays for a prescription under the plan. The sum of those costs is the total out-of-pocket. This is what the insured party must pay in addition to the monthly premiums. Finally, the total annual cost is the sum of the total out-of-pocket and premiums. We'll start this table with the smallest amount of medical charges that would be possible, assuming 3 visits to providers. The visits would be charged at $350. We'll also include 2 other charges on our way to charges equal to $1,200, where the deductible is met. Since the Basic Plus plan does not split these charges until the deductible is met, the insured party must pay for all of these charges. The generic prescription is charged at $30 per month. However, the cost is $10 per month with no deductible, so the annual prescription cost is $120. If we add these amounts together, we get the total out-of-pocket at the different charge levels. For the Basic Plus plan, the monthly premium is $46 for an annual cost of $552. By adding the total out-of-pocket to the premium for the year, we get the total annual cost of the Basic Plus plan for several charges before and up to when the deductible is met. As expected, as the charges increase, the total annual cost also increases. Now let's examine charges that are incurred after the deductible is met. So we'll start at $1,200 and increase the charges by $5,000 or $10,000 in each row of the table. The corresponding costs are calculated using the fact that the insured party is splitting the charges with the plan on a 60-40 basis. This means that the insured party pays 40% of the charges above the deductible, and the plan covers 60%. For instance, let's examine the amount paid by the insured when the charges are $6,200. At this level, the insured party pays the deductible plus 40% of the charges above $1,200. This amounts to $3,200. The other entries in the column are calculated in a similar manner. Once we have those costs, we will fill in the rest of this section of the table as before. Notice that the out-of-pocket maximum of $12,000 is exceeded in the last row. We need to know the exact amount of medical charges at which the total out-of-pocket is exactly $12,000. To find this, we solve an equation corresponding to the deductible, plus the coinsurance, plus the prescription costs set equal to $12,000. The solution to this equation is x equal to $27,900. If we change the last row to correspond to $27,900 in medical charges, the total medical cost is $11,880. For this amount of charges, the total annual cost is $12,552. For any amount of charges above $27,900, the total out-of-pocket is $12,000 and the total annual cost is $12,552. If we graph the total annual cost as a function of the total medical charges, we see three line segments. The first segment corresponds to charges where the plan deductible has not been met. The middle segment corresponds to charges after the deductible is met, but before the out-of-pocket maximum is reached. The last segment matches the charges after the out-of-pocket maximum is reached. To find the piecewise linear function for this graph, we'll use the slope-intercept form of a line with x representing the total medical charges and y representing the total annual cost. The slope of the first line segment is found by using 2 points from that section. Once we have the slope, we can use it to find the y-intercept of that section of the graph. This gives us the line y equal to x plus 672 for x values from 350 to 1200. We'll use 2 points from the next segment to get a slope of 0.4. The equation of this segment is y equal to 0.4x plus 1,392. This segment is valid for charges greater than 1,200 and less than or equal to 27,900. The total annual cost in the last segment is a constant. This yields the line y equal to 12,552 for charges greater than 27,900. The piecewise linear function corresponding to these segments reveals an interesting fact. The slope of each segment is the percentage of charges the insured party pays. Before the deductible is met, 100%, a slope of 1, of the charges is paid. After the deductible is met, but before the out-of-pocket max is reached, the insured party pays 40%, a slope of 0.4, of the charges. Once the out-of-pocket max is exceeded, the insured party pays 0%, a slope of 0, of the medical charges. Plans with copays are handled a bit differently. In the Premier plan, there is a $20 copay for office visits to the primary care physician with no deductible. Additionally, specialist visits require 20% coinsurance with no deductible. So the 2 office visits and 1 specialist visit will cost $70. The deductible is reached once an additional $600 in charges are attained beyond the visit charges. The insured party pays all of those additional charges. Using 2 points from this table, we can find the slope and y-intercept of the line. Before the deductible is met, the equation of the line segment is y equal to x plus 6,008. This segment is valid for charges from $350 to $950. Once the coinsurance kicks in, the total medical cost is calculated by adding the deductible, the cost of the visits, and the 20% coinsurance of all charges above the deductible and visit charges. To determine the charge at which this occurs, form an equation with the out-of-pocket maximum of $6,000 on one side and the total medical cost plus the prescription cost on the other side. The solution to this equation is x equal to 27,000. Putting this into the last row of the table gives us the point at which the total out-of-pocket maximum is reached. Now we can use the 2 points in the table to determine the equation of this line segment. This segment's equation is y equal to 0.2x plus 6,768 and is valid for charges above $950 and less than or equal to $27,000. Note that we could have used any pair of points to find this line. Since this function is continuous, it is not crucial to use charges that are strictly in the region. Charges on the border work just as well. The total annual cost in the last segment is constant. The equation of this line segment is y equal to 12,168. This equation is valid for charges greater than $27,000. As before, the slopes on this piecewise linear function correspond to the percentage of the charges the insured party is responsible for. Graphing these functions together gives us a complete picture of these two plans. The point of intersection gives us the level of medical charges where the total annual medical cost is equal. This occurs in the second segment for each plan. Setting the functions for these segments equal give us a charge of $26,880. If the amount of medical charges is less than $26,880, the Basic Plus plan will be the cheapest. If the amount of medical charges is greater than $26,880, then the Premier plan is cheapest. However, keep in mind that there is only a small difference between the plans once the amount of charges exceeds $26,880. To get students to carry out this process, I use several technology assignments to help them organize the information in the plans. Through technology assignments, students discover a possible solution strategy. Each assignment guides the student through the solution strategy with a generic set of insurance plans which they will need to adapt to different plans. I try to group the main parts of the strategy into logical groupings. The first two assignments are designed to ease students into the project and introduce them to the terminology needed for the project. In the last two assignments, they utilize Excel and learn how to use it to do calculations and make graphs. In each assignment, there is a file which the student submits for a grade. I try to make these files incredibly easy to grade so that I can get through a class of 30 in under 2 hours. It also gives me an opportunity to give each student feedback on their work. The first technology assignment introduces them to the idea of a spreadsheet and teaches them how cells are named as well as how to format individual cells, rows, and columns. However, I don't want them to simply duplicate what I've done for the Basic Plus plan and the Premier plan. I want them to work with 1 or 2 plans of their own choosing. This semester, I decided to make the project a little easier by demonstrating the process with the Basic Plus plan and then having them carry out the same process with their own plan. In this case, they compare their own plan to the Basic Plus plan. They can locate plans customized to them at the website ehealthinsurance.com. They start by putting their zip code into the web page. Then they put their information for individual coverage or their information and that of their dependents if they are interested in family coverage. This website requires applicants to be at least 19, so I ask them to adjust their age if they are not 19. Once they click Go, they will be given a large number of plans to choose from. I ask them to select one high deductible plan and a low deductible plan. I also urge them to select different plans with different coinsurance requirements. This ensures that the graphs of the two plans cross. When they compare the plans, they will be able to see side by side how the coverage compares. They can use this information to create an Excel worksheet with the plan details. The handout for this technology assignment assumes that each student has never used Excel. It explains each step with plenty of graphics to ensure students do not get lost. If they do get lost, the steps are numbered so that they can refer to those numbers when emailing me about the assignment. However, creating a table in Excel of charges and costs is very difficult when you are still learning the insurance terminology. For this reason, I have students work out charges and costs on paper before working them out in Excel. This gives them a chance to explore the difference between charges and costs, copays, deductibles, and out-of-pocket max. They will need a lot of feedback on this assignment so that they can focus on Excel in the next assignment. In the third technology assignment, they will use plan details to create a table of values like the one I showed earlier. I emphasize utilizing the features in Excel like fills and cell references so that the worksheet does the work for them and they can verify any information that they calculated by hand. They also learn how to graph the charges and cost columns in their worksheet. I have them do this on 2 separate graphs since it is easier than trying to put the graphs together all at once. In the fourth technology assignment, they put the graphs together, find the piecewise function, and locate the point of intersection. Now that you've had a chance to see the project, let's look at some frequently asked questions. First of all, how many projects do I give in a typical semester? In college algebra, I use 4 projects. In the college cost project, students use data for college costs in the U.S. states to create linear models for costs. The medical insurance project is the project described in this presentation. In the dating rocks project, students model the exponential decay of potassium-40 to date rocks. Students complete each of these projects in a 4 to 6 week window. The last project, making beads, is administered in a 48-hour period at the end of the semester. In this project, students use matrices to find the total cost of raw materials in jewelry. What is a typical timeline for a project? The medical insurance project is the project my students are currently completing. They started the project in mid-February and completed the first 2 technology assignments while completing the matrix algebra portion of the class. In these assignments, they are working on understanding how insurance terms relate to mathematics. Since they do not need the matrices they are learning about in this class, there is no issue with not knowing the prerequisite mathematics. Most of what they are doing is working with percentages. Just prior to spring break, students use Excel to compute the total annual cost of medical insurance at several different charge levels. This is the most challenging aspect of the project. I immediately grade the Excel files they submit. Then during spring break week, I can respond to questions I get from students about fixing what they have done. It is very critical that they have correct tables for their health plans before moving on to the next technology assignment. Just as we cover piecewise functions in class, students find the piecewise linear functions for each health plan in their project. Then they have a little over a week to complete the documentation that they will submit for the project. In total, they complete this project over 6 weeks, with one of those weeks being spring break week. How do you manage to teach students to use Excel without using a lot of class time? Class meetings are very important. I like to use them to accomplish tasks that would be difficult to do online. I find that I am able to use videos that I have already created to teach the basic procedures of college algebra. I utilize them within my math lab and media assignments. In the media assignments, I am able to incorporate the videos and handouts as a part of the homework. This ensures that the students have access to the resources they need as they complete the homework in my math lab. Students must get at least 75% on any homework assignment before they can complete the corresponding quiz. During a typical week, like February 19th through the 25th, students work on a media assignment for sections 7.1 and 7.2. They are working to attain 75%, and there is very little coverage of these topics in class. The following week, on Monday, February 27th, the homework is due. I examine the results of the homework and use it to plan the first class meeting of the week from February 26th through March 3rd. I can generally cover all of the problems students had trouble with in about half of the class. This leaves the rest of the class meeting for in-class activities, learning about Excel, or discussing important aspects of the project. During the second class meeting of this week, we continue these activities and then introduce the topics for that week, 7.3 and 7.4. Students essentially complete the homework prior to the class meetings and use the class meeting for concepts that they have trouble with. This is my version of the flipped classroom. I break their grades down to 20% homework and tech assignments, 30% quizzes, and 50% projects. This ensures that they are not penalized a huge amount for any one item. How do you assess student learning on projects? You can end a project by having them write up a paragraph or so on which plan they would choose and why. I like to have them put together a formal document explaining the process they went through. I call this document a technical memo. It consists of 4 sections. In the first section, the introduction, they explain what the problem is, the data they used, any assumptions they made, and what they will prove. The second section is the methods section. In this section, they define all terms, like deductible and coinsurance used in the project, as well as any variables and function they will utilize. Explaining the relationship between the different quantities, like total medical charges and total medical cost, is also required. If they have any procedures, like finding the equation of a line from 2 points, they need to talk about that procedure in this section. In the results section, they carry out the strategy outlined in the methods section. Students have a tendency to want to write a solid mass of equations without any explanation. Getting them to use sentences and mathematics is like pulling teeth. For this project, ending the results section with a comparison graph is a good ending point. This allows them to use the discussion section to explain what plan should be chosen and why. I also ask them to look at the big picture and talk about that too. I grade the technical memo in 5 areas, each on a 7-point scale. I use a rubric in each area. They can earn a total of 35 points. Since this is the first or second time any of the students have written a document like this, I don't expect that they will be able to get a perfect score. I take their score out of 20 or 25 points, with any additional points being extra credit. On later projects, I raise the maximum until the max is 35 points on the last project. The extra credit is at the beginning of the semester instead of at the end of the semester. This accomplishes 2 goals. First, it gets them working hard at the beginning of the semester. The better they do on this project, the better they will do on later projects. Second, many students will have a very high score on this first project. Because of this, they are highly motivated for the rest of the semester. Isn't this a lot of work? It certainly is a lot of work to utilize projects in a class. However, there is a number of things you can do to minimize the workload during the semester. To the largest extent possible, have the class completely prepared before the semester begins. You don't want to spend the semester writing resources. The students will demand more of your time than you anticipate. Use the project materials for more than one class. For instance, I use almost the same materials you see in this project in a calculus project. In this project, students take the mathematical model they have developed and prove it is continuous. Another possibility is to use some type of automated homework and quiz grading system. This cuts down on the standard homework grading you see in a typical class. Instead, focus on assignments where your grading adds value to the assignment. This means you are using the assignment to check their progress or to give them feedback on a critical component of the course. If you'd like more information on this and other projects, check out my website, pblpathways.com. You'll find some actual technical memos written by students, the handouts used in the technology assignments, videos I use in conjunction with the technology assignments, as well as 23 more projects. If you're interested, you can also check out the blog I maintain for students at ycmath.com.